Good morning, Miss Aruna and my fellow friends. My name is Onion Lin and this is my teammate. We are all come from FIE Group. Today, we will discuss the three assignment questions. Without further delay, I will begin with question 1. For this question, we will use the linear regression method to find the regression line. This is the graph which we generate using linear regression method, where x represents the year and y represents the carbon dioxide level in parts per million. You can use tools like the Demos Graphing Calculator or Excel to generate the trend line by inputting the data. To obtain the trend line equation, we first need to find the gradient. We can do this by selecting 2 points that lie on the line. Here, I will choose 1974, 329.6858 and 1988, 350.6396. Applying the formula m equals to y2 minus y1 over x2 minus x1 gives us the gradient, which is approximately 1.4967. Then, we substitute the gradient and the point 1974, 329.65858 into the equation y minus y1 equals to m x minus x1. Solving this, we obtain the equation y equals to 1.4967x minus 2624.8. Next, we can estimate the average CO2 level for 1987 using linear interpolation method. This involves zooming in on the graph to find the precise point for x equals to 1987. Alternatively, we can approximate by substituting x equals to 1987 into the equation, giving us an answer of about 349.1 parts per million. Now, Qiyuan will discuss the remaining parts. Thank you.
Thanks for the explanation. Now, let me introduce myself. My name is Wang Qiyuan from Foundation in Engineering, and I will be the one to talk about the calculation to predict the carbon dioxide level for year 2005 and the year carbon dioxide level exceeds 400 parts per million. Let's start with the first one. So, this is the extrapolated carbon dioxide level graph. By using linear extrapolation method, we can get an estimate answer for it. For now, we are going for the carbon dioxide level for the year 2005. By using the graph, we can zoom in and find the answer for this question. As for another option, we can substitute x as 2005 into the equation we obtained. After the calculation, we will get the answer for the carbon dioxide level for 2005, which is 376.1 parts per million. So, moving on. We are going to find the year that carbon dioxide level exceeds 400 parts per million. The subject of the question has changed. Instead of finding carbon dioxide level for corresponding years, we are going to find the year that exceeds the certain carbon dioxide levels. So, as usual, there are two ways to solve this question. Let's start by talking about the linear extrapolation method. By looking at the extrapolated graph, we can find a precise point that exceeds the 400 parts per million of carbon dioxide levels. On the other hand, we can also use the substitution method. Instead of substitute x, we are going to substitute the y which represent the carbon dioxide levels. By substitute y as 400, we can get the year that exceeds the 400 parts per million of carbon dioxide levels, which is 2021. That's all from me. Next, I will pass down the presentation to my teammates, Yue Yang.
Thank you, Qiyuan. My name is Hui Yang. Let me introduce to the problem of question 2. We are given a conical tank being filled with water at a rate of 30 centimeters cubed per second. The radius of the tank at the top is 10 centimeters and the height is 20 centimeters. The task is to determine the rate at which the water level is rising when the water is 10 centimeters deep. Firstly, let us analyze the given information. As the rate at which the water level is rising when the water is 10 centimeters deep, means that how fast the water level or height in the tank is rising as water is added until 10 centimeters. So the question asks for dH over dt, the rate of change of the height with respect to time, or simply the rate at which the height is increasing over time. Moreover, we know that the water is being added at a constant rate of 30 centimeters cubed per second, which is dV over dt equals to 30. The total radius at the top of the tank is 10 centimeters and the height is 20 centimeters. So let's us set up the relationship between radius and height. Since the tank has a conical shape, as water fills the tank, both the water radius and height are related proportionally. We set up a ratio using similar triangles, which is R over H equals to 10 over 20. This implies that at any height H, the radius R of the water level is 1 over 2H. Since R equals to 1 over 2H, we substitute this into the volume formula of a cone, which is V equals to 1 over 3 pi R square H to express V socially in terms of H. In the end, we will get V equals to 1 over 12 pi H cubed. For the next part, let's pass it to my teammate Jiaxuan to complete the rest.
Thank you, Yue Yang. My name is Di Jiaxun. Now, I will continue explain this question. We are given dV over dt are equals to 30 cm cubed per second. To find the rate at which the water level is rising dH over dt, we need to differentiate V equals to 1 over 12 pi h cubed with respect to h. Hence, dV over dH equals 1 over 4 pi h squared. Now, we can substitute h equals to 10 centimeter cube into the equation. So, we can get dV over dH equals to 25 pi. In this step, we can inverse it into dH over dt equals to 1 over 25 pi. You can use change rule, which means dH over dt equals to dH over dV times dV over dt. Next, we substitute dH over dV and dV over dt into the equation. So, we can derive that dH over dt are equals to 6 over 5 pi centimeter per second. Or you can write it as 0.382 centimeter per second. That's all for me. Now, I will pass up to my teammates.
Alright, thank you Jiaxun for the explanation. My name is Go Yuanling, and I will continue the presentation. Next, let's move on to the last question, question 3. This question involves deriving the velocity of blood flow from a given distance model. As you can see from the question, we have a function that models the distance traveled by blood in terms of time, and our final goal is to find the velocity. Hence, we need to differentiate this distance function in order to obtain the velocity function. But before that, let's take a look at the explanation of the model component first. First and foremost, what does the 20 represent? The term 20 centimeter per second represents the average velocity of blood flow. Besides, the term 5 sine 7.85 t introduces a pulsatile variation. This simulates the blood flow change due to the heartbeat, with an amplitude of 5 centimeter per second. Last but not least, the angular frequency 7.85 radian per second correspond to about 75 heartbeats per minute, representing a typical heart rate. Alright, now we all roughly understand the topic. Let's start our calculation by differentiating the distance function using the product rules. As dt is the product of two functions of t, we will use the product rule for the differentiation. And this part, I will pass to my teammate Henry to discuss about the details of differentiation.
Okay, thank you, Yuanling. So, my name is Henry Lee, and I'll be continuing from where Yuanling left off. So, we're going to use product rule. So, let's let x times t equals to 20 plus 5 sine 7.85 t, and let yt equals to t. So, xt will be equals to 20 plus 5 sine 7.85 t, and x prime t will be equals to 5 cos 7.85 t times 7.85. Hence, x prime t will be equals to 39.25 cos 7.85 t. Let's let yt equals to t. Hence, y prime t will be equals to 1. Furthermore, v equals to d over dt times dt will be equals to v equals to dt over times 20 plus 5 sine 7.85 t times t again, and v equals to d over dt times xt times yt will be equals to v equals to x prime t times yt plus xt times y prime t. Hence, v equals to 39.25 cos 7.85 t times t again, plus 20 plus 5 sine 7.85 t times 1. So, overall, the answer v will be equals to 39.25 t cos 7.85 t plus 20 plus 5 sine 7.85 t. So that concludes our presentation. Thank you everyone and I hope you all can understand what we explained and felt intrigued and inspired to do more maths. Thank you everyone.